All right, it's Friday, August 22nd, and we're starting the second chapter where it's really the chemical foundations of biology. And so we're going to talk about the basic features of atoms. We'll talk about electrons and valence electrons, how they determine the chemical bonding and reactivity of an atom and the formation of molecules. We'll talk about water as an example of a chemical, and that's going to be our introduction to chemistry. Okay, chemistry is really the study of matter. Okay, that's anything that's a solid, a liquid, or a gas. In chemistry is of course related to biology because biology deals with the matter of living organisms, and so we wind up doing a lot of chemistry. I know chemistry scares a lot of people. Um, it's it's somewhat abstract. If when you take chemistry, there's lots of chemical equations that you have to balance. There's all these abbreviations to memorize and equations. Chemistry can be difficult, but if there is a logic to it and an order to it. In biology, we don't do what chemists do. We don't study chemistry in the way they study it, but we often work together with chemists. We often study similar things, um, but we have a different approach. And that approach is evidence here because we won't do equations and we'll try and avoid abbreviations and there's no balancing. I'm hopeful that some of you have had a high school chemistry or are in chemistry now. If you're going to major in biology, often you have to do a fair bit of chemistry because it's related. But biology and chemistry are somewhat different. And so, that's it. Many of you are probably going to major in chemistry. I don't know for sure. So atoms, what is an atom? Well, one of the things chemists did was try and separate materials into their most basic components, and then see what they were. And they found that when they did this, that they could identify 92 naturally occurring elements. And each of these elements, the smallest particle, they were identified as atoms. And all atoms are made of the same subatomic particles, but they have different numbers and arrangements of those particles. And so, like here, they show a hydrogen atom, which has one proton in its nucleus and one electron. Okay, and that's on top in the group 1, the first thing there. And the group 18, the second simplest atom, is helium, and helium has 2 protons and 2 electrons. And so there's abbreviations there, and it shows the arrangements of electrons, and that turns out to be important for the chemical properties of an atom. And if you've had chemistry, you've probably seen this chart. We don't memorize it, we don't use it much, but I show it once or twice. This is the periodic table of elements, and the columns of each row here, or each column in this, contains atoms that have similar properties. And they were grouped by their properties, and then the atoms are grouped by their size. And so in the upper left there is the helium atom or hydrogen atom, and the little box there is expanded on the bottom. Hydrogen has a symbol of H. It has an atomic number of 1, which means it has 1 proton in the center in its nucleus. And when it's uncharged, it will have 1 electron going around. And then its atomic mass there is the weight of the atom. Okay, we won't have to know any of that. I will sometimes use H as an abbreviation for hydrogen. Okay, generally, what makes an element or an atom a particular type of atom is the number of protons there. So that atomic number is very, very important. The number of protons determines the type of atom. There can also be a second particle in the nucleus of an atom in the center, and that is the neutron. And neutrons don't really affect the type of atom, but they do affect its weight. And to a certain extent, sometimes having large numbers of neutrons can mean the neutrons are unstable and break down. Okay. Atoms of one type that have different numbers of neutrons are referred to as isotopes. Okay, neutrons affect the weight, but not so much the property. But they sometimes break down, and so some of these, like carbon 14, is an unstable isotope, and eventually will give off a couple neutrons. Okay, so in the center of the atom, we call that the nucleus. That's where the protons and neutrons exist. Outside of the nucleus, you have um, energy levels where electrons are moving around the nucleus. These these are sometimes referred to as orbitals or uh, have other names for them. And these electrons are available for atoms to interact. And atoms definitely prefer having certain numbers of electrons in their orbitals. When you get into chemistry, they'll go into the shape of these. I'm not going to do that so much. But these electrons are moving and they move in particular orbits, and different orbitals have different shapes. What's really important here is the outer orbitals are referred to as, the electrons that are there are referred to as valence electrons. And those valence electrons, there are certain really stable arrangements. If the orbital is filled with either 2 or 8 of these electrons, the atom is relatively stable. And atoms, another stable number is 0, having 0 electrons in these. So in some cases, atoms will give up an electron to get to 0. In other cases, atoms will accept an electron to get to 8 electrons. Okay, when this happens, each atom becomes charged, and opposite charges attract, and we refer to this as an ionic bond. Okay, the atoms that give up these or take these electrons that charge, if they gain a positive charge, they're referred to as cations. If they wind up with a negative charge, they're anions, and these opposite charges attract. This is referred to as an ionic bond. Okay, lots of things like table salt are made up of atoms that have gained and lost electrons. And so this is one way we form compounds. Another way we form compounds is through covalent bond. And in this case, atoms can share electrons, where the electrons will orbit 2 different atomic nuclei. And so they'll spend time around each atom, and this will hold the atoms together. And so the atoms are shared in pairs, and so they can share 1 pair, or sometimes down below here you see they can share 2 pairs. Neither atom generally becomes fully charged. Sometimes there's a little kind of a little partial charge, but in this case it's the electrons are orbiting both, and so this holds them together. The more electrons they share, the closer they're held together. So when you ask the question, what makes an atom form bonds with other atoms? It's to get a stable arrangement of electrons. Okay, that's really, really important. They can give up electrons, they can take electrons, or they can share electrons. And so this is what forms molecules or compounds. And that's really important in biology and other places as well. Okay, what's the next question here? Where do biologists find cells? In all living organisms. But you could say wherever they look, really, but not totally. Okay, one thing I have to talk about with covalent bonds is sometimes molecules are sharing electrons, but not totally equally. And so these electrons, parts of these molecules have more electrons and become kind of partially negative, and parts of these molecules have less electrons and become partially positive. And when you get a bunch of materials that have this, the partial positive regions of one molecule are attracted to the positive negative regions of another molecule. And this causes a weak interaction between the molecules referred to as a hydrogen bond. Okay, the best example of this happens in water. In water, you have 1 oxygen and 2 hydrogens, and water molecules, the hydrogens and oxygens share electrons, but the electrons spend more time near the oxygen. So the oxygen is partially negative, and the hydrogen regions are partially positive. Okay, and so water molecules interact with partial negative and partial positive regions of different molecules lining up. This is what gives its water its unusual properties, is these hydrogen bonds. It makes water stable, a liquid. It makes it have surface tension, all sorts of things like that. So, and water is very good as a solvent. Water molecules can help dissolve things like ionic substances like salt. And so these partial negative and partial positive regions line up near the negative and positive ions that you find in ionic substances. Okay, this is why water is really important for living organisms. All cells are mostly water. They contain liquid solutions, water solutions of a variety of different chemicals. This is the it's true of all living organisms, and these weak associations between water molecules and other molecules are crucial for life. Um, Things like surface tension, movement of water through tubes, which we call adhesion, these are all depending on these hydrogen bonds between water molecules. Um, that's cohesion and adhesion there, and so you see that there. Water also, because these molecules want to stay together, water remains a liquid. It's hard to vaporize water because you have to break these hydrogen bonds, and so water remains a liquid even at high temperatures. It also means that water molecules that are unfrozen are actually closer together than water molecules in an ice crystal. This prevents ice from forming in the middle of a body of water, but it only forms at the surface. This is also the reason water is a good solvent, and it can organize all sorts of things into particular shapes. Water can also ionize. It can form hydroxide ions, OH minus, and hydrogen ions. These things participate in chemical reactions that are crucial for the body. So there's lots of really important characteristics of water for life. And when we're looking for life in outer space, like on Mars or in a moon of Saturn, Europa, what we're really first looking for is evidence of water. That liquid water is or was available on this planet. And so we look for minerals that form in water. We look for features that suggest there was flowing water. We look for water that's present currently. This is the crucial feature that we're looking for. We spend lots of time doing that. Okay, so next time I will talk more about other types of molecules. I'll review this, and we're kind of deep into chemistry, but we're not doing any chemical equations. We're not memorizing much yet.